This one. Document ke? Okay. Cuma sama. Ini ke? Oh, bukan yang ni. Sorry. My bad. Hmm. Screen. Has everyone tried it before? I mean the questions. Ada tak orang yang dah buat? Ke semua tak sempat? Copy dulu.
Azri.
Oh, Fazli. Fazli dah,
Azri.
Azri dah buat. Oh, cemerlang. Okay, insert page break. Okay.
Hadi pun dah siap semua, Doktor.
Wow, bagusnya. Okay, tak apa, nanti kita semak sama-sama. Ke Hadi nak share dengan kita? Hadi nak share ke?
Tak.
Okay. How is everyone doing? Okay ke kat rumah? Banyak gangguan tak? Tengok muka stres je. Sebab belajar fizik. Banyak lagi yang tak buka. Ada lagi yang tak buka video ni? Are you guys okay? Safia Saad? Okay. Bagilah saya tengok, nanti saya lupa muka macam mana. Betul nanti korang upset, saya tak ingat student saya. Buka lah video tu, susah aku nak jumpa korang. Okay, anyways, let's start with the first question. At what height at what height above the Earth's surface where the gravitational acceleration is 1/10 of its value at Earth's surface? So dia tanya height berapa? Let's say kita ni, this is Earth and you have your gravity over here. Dia tanya what is the height from the center. Oh, kenapa suara saya bergema? Sekejap saya pakai earphone. Kena turn off mic tau, nanti suara saya bergema. Korang kena turn off mic. Okay. Dia tanya what is the height of the object for the gravitational acceleration to be 1/10 of its value at the Earth's surface. So kiranya at this point the value is F1 lah, let's say. Dekat sini the value is F2, it's different. So dia tanya what is F2 over F1 that is 1/10. Nak cakap F2 over F1 is 1/10 and what is the height of F2 ni lah. Okay. So kita tahu gravitational acceleration it changes with height. Macam mana kita tahu? Kita tengok daripada equation yang kita dah belajar sebelum ni. Okay. So the equation that we learned before, let's just do a little recap. It's F, gravitational force is equal to G mass 1 mass 2 over radius between 1 and 2 squared, right? And if we are on a planet, if I'm talking about acceleration where F equals to ma, how do I get A from this equation? I get rid of one mass. So how do I get rid of one mass? Is Fg equals to mass of object, acceleration on the planet equals to G mass of object, mass of planet over radius of planet squared. And I told you if the object is on the surface of Earth, where the height is negligible or the height is very small, you can just not put it into the equation, right? But if the height is very large, your equation becomes G mass of object, mass of planet over R planet plus height squared. Okay, so the difference in acceleration between these two positions, let's say this is position 1, sorry, position 1 plus A, position A, position B. So position A is down here, position B is up here. So this guy is your FG at position B, and this guy is your gravitational force at position A. So equation dia lain, which means that the value is also different. Saya recording ke? Saya recording. Okay. Okay. So at the force of gravity at position A is just this equation. The force of gravity at position B, equation dia lain tambah H squared. Okay. So now that we know that memang gravitational force lain, how do we calculate for the acceleration? I told you before, F equals to ma. Kalau kita nak cari acceleration or the gravitational acceleration, what do? We take out the mass of object. Take out mass of object. Okay, so my equation now becomes oopsie. Oh no, don't choose it. Sekejap lupa nak padam. Okay, so now my equation, which is what the question is asking. So acceleration at point A is take out the mass of the object, so it becomes G mass of planet over radius of planet squared. And the acceleration at B is acceleration at B is G mass of planet over R plus H, RP plus H squared. Okay, so cakap what is the height so that the ratio between these two acceleration is 1/10. So 1/10, kita nak tahu is it acceleration B over A ataupun acceleration A over B. Okay, let's read the question again. At what height above the Earth's surface where the gravitational acceleration is 1/10? Maksudnya it's B over A is 1/10, right? So AB, let me write that. According to the question, it says it's asking for AB over AA is 1/10. And we know the equation to this is this guy over here. So I'm just going to put that in. MP over RP plus H squared divided by acceleration at A, GMP over RP squared. Okay, is everyone following me so far? Okay ke? Okay, kalau if you have questions, just let me know. We're doing revision siap-siap for your test for this particular chapter. Sementara semua orang masih ingat to revise balik. Okay, so now that I have this equation and it is equal to 1/10, I can eliminate, I can cross it out. Sekejap, kenapa? Oh. Okay, so G is crossed out by G, MP is crossed out by MP, and now I am left with RP plus H squared dekat denominator, and this guy is RP squared denominator. So it becomes dia jadi ke atas lah kan. So now it becomes issue. Okay. Do I have enough space? Okay. So now it becomes RP squared over RP plus H squared equals to 1 over 10. And we know what RP is. It is the radius of Earth. It's a constant. The value will be given for you in your test. So just plug in that value. RE is equal to berapa? 6.38 ke? Times 10 to the, I don't remember. So RE is
Times 10 to the 6.
times 10 to the 6. Meter kan? Ke
Yes.
kilometer? Meter ke kilometer?
Meter.
Meter eh? Okay, so tak payah convert dah. So it's in meter, so you don't have to convert. So plugging in that RE, so this will give you 6.38 times 10 to the 6 squared. And then 6.38 times 10 to the 6 plus H squared and 1 over 10. And saya tak solve lagi. So this is how you do it. Saya nak ajar macam mana nak buat je. Tekan-tekan calculator, I leave it to you. So I don't know what H is. Okay, so the final answer is the height of the object is, let's say, tak nak cakap let's say, the height is blah 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 meter. You always have to put in units. Okay, kalau tak ada unit, tolak satu markah. And that is what happened during your assessment. You forgot to put in your units. Walaupun dia dah tulis dalam instruction, you guys still forgot. And I reminded you, you still forgot. You didn't put the units. Okay, penting sangat tulis unit ni. Tak nak hilang markah free-free. Okay, rugilah. Okay, yang part unit ni memang tak boleh kasih markah kesian walaupun jawapan betul. Memang tolak satu markah. Okay, so please do your best. Jangan lupa-lupa tulis unit. Okay, penting. Okay, so that is how you solve for that first question. How did we do it? Saya tak substitute value up until the last part. What I did was I identified what was the equation that I needed to use. So the equation that I needed to use was acceleration, right? So acceleration, I defined the acceleration at point A, which is at the surface. I defined acceleration at a certain height, which is this equation. I did not use any numbers yet here. Why? Because I wanted to cross it out. Senang. Kalau saya letak nombor siap-siap, saya kena kira lah daripada awal. But if I use the equation as it is, I can cross it out and then it makes my calculation much more easier. Right? Alright, so next question. How large must the any questions for me so far for that question? Okay ke? Tengok muka jap. Okay.
Doktor,
Yeah.
how can we know the acceleration for A and acceleration for B yang kita kena compare tu?
Yang tu equation. Maksudnya awak tak tahu macam mana kita dapat equation ni ke?
Yes, tak faham yang acceleration B over acceleration of A.
Oh, daripada soalan ni awak tak faham yang dia cakap acceleration B over acceleration A ke?
Yes, sebab saya cuba buat terbalik.
Oh, okay. So dia tanya, at what height above the Earth's surface where the gravitational acceleration is? So yang ni kita cakap acceleration B kan? Yang ni acceleration A. So dia tanya, at what height above the Earth's surface is the acceleration 1/10 of its value on Earth's surface? So maksudnya, value of AB ni is 1 over 10 of AA. Betul tak? Daripada soalan ni, AB value dia 1/10 daripada AA. Okay, ni cara nak tengok dia. And then if you know that the question said AB ni value dia 1/10 daripada AA, so awak rearrange this, you will get, alamak jadi balik. Dude. Pen saya ni tak cooperating. Okay, so AB over AA is 1 over 10, which is the same thing that I did. Okay, kalau tak nampak, saya terus AB over AA equals to 110. Write down what you can understand from the equation. Dia cakap, gravitational acceleration is 1 over 10 of its value at Earth's surface. So 110 value of acceleration at Earth's surface is A at height. A at height kita define as AB, 1 over 10. A Earth's surface kita define as point A. So AA, sama je. Is that okay? Okay ke?
Yes, okay. Thank you.
Okay. Penting, itulah kadang-kadang tak faham soalan kan. So you have to be really careful. Okay. Okay, next question. Okay, how large must the coefficient of static be between the tires and the road if a car is to round a level curve of radius 85 meter at a speed of 92 km per hour? Okay, when you are given the speed like this, you have to convert to SI unit. Jangan pakai as it is. Please always convert. When you convert, you will get marks for conversion. Dia memang takkan biarkan awak tak dapat markah if you convert. So how do you do that? You want to convert kilometer to meter, you want to convert hour to seconds. So that's your SI unit. So 1000 so 1000 meter is, alah kenapa ni? Why does it keep happening? Okay, please work. Okay, so 1000 meter is 1 kilometer. So you want to get rid of kilometer, you put it down here. And then 1 hour is 60 minutes times 60 seconds, right? So it becomes 60 times 60, sama je. And then this becomes, don't know, 92 times 1000 divided by 60 divided by 60 gives you 25.56. Okay. Right. Okay, so now we go to the question. How large must the coefficient of static be? Tanya coefficient mu. Dia bukan tanya friction force, dia tanya coefficient of static, which is static friction lah, tapi the coefficient which is mu. Between the tires and the road, if a car is to round a level curve of radius at speed 92 km per hour. Okay, so the question is saying what happens, what is the static coefficient if I have a car over here and it is di tengah bawa kereta in a round road where the radius of road ni is berapa tadi? 85 meter, right? Okay, so whenever we have a circular road, whenever we have a circular hill, whenever we have a Ferris wheel, we have a roller coaster, semua yang melibatkan bentuk circular, walaupun separuh je circular dia, we will have centripetal acceleration. Okay, let me say that again. Whenever we are riding on a circular road, on a circular hill, roller coaster, Ferris wheel, anything that has circular punya shape, walaupun sikit je, walaupun secorak ni je circular dia, it will have centripetal acceleration. Even though it's not a full circle, even though it's a half circle, it will have centripetal acceleration. So now from this problem, it is saying it is traveling on a circular road, right? Which means that centripetal acceleration is there. So now we know that our centripetal acceleration punya direction is towards the center. Okay, assuming this is my center. Jauh pula center saya kat sini. Let me draw that again. So radius can be anywhere. Let me draw the radius over here. Okay, that's my radius. Okay, equals to 85 meter. Okay. So now I know that my centripetal acceleration punya direction is always towards the center of the circular motion. The center of the circular motion is here, which means that my acceleration, centripetal acceleration is, why does it keep happening? My centripetal acceleration also points towards the center of the circle. Wai, lukis untuk jadi. Okay, pandai-pandailah korang. Yang ni towards the center tau. Okay, center besar sikit. Okay, dia capai center. Okay, so that is my AC. Now, tanya, what must be the coefficient of static? Remember, when we have a car that is travelling on a circular road, we have static friction. Okay, siapa yang tak ingat tu, let me show you the slide again. Kau tak ingat? Mana? Chapter 6. Static friction is, terus sampai. So when we are travelling on a circular road, static friction is in this direction. In this direction. So this is your static friction. Fs. Okay, so drawing the free body diagram for this car on a circular road, this is my reaction force. This is my mg. Do I have anything else? No. And where should my centripetal acceleration be labeled at? I can just label it like this, AC. Okay, why is it not part of the free body diagram? Because it's a condition. Remember? Kita copy gambar ni, masuk balik kat sana. Okay. Whoa, not that one. Okay, copy that. Masuk balik gambar sini. Sebab gambar saya buruk. Okay. So now I can write the equation for my free body diagram. So always we start with our condition. The first thing to write is condition. Okay, so condition FR. The net force in the radial direction, radial is always pointing towards center. The net force in the radial direction punya condition is MAC, which is also mv squared over r. This is just the equation. Okay, you can write MAC, doesn't matter. And looking at your free body diagram, what is in the radial direction? It is only static friction. So net in the FR is also equal to Fs. So now your equation becomes MAC equals to Fs. What is MAC? It is mv squared over r. What is Fs? It is mu r. How do you solve for r? Solve for r using your net in the Fy. So net in the Fy, is it in equilibrium or not? Can anyone answer me? Is your net in the Fy in equilibrium or not? Should it be 0 or MA?
Yes.
0.
0. Why?
0.
Because not flying.
It's not flying, betul. Thank God you got that. Okay. Because it's not traveling upwards or not traveling downwards, it's just on the road, it is in equilibrium, at least in the y direction, it is in equilibrium. So that means that I have positive r, if I'm saying positive goes up, and negative mg. So r is just mg, because r minus mg equals to 0, right? So r, just rearranging that equation gives me r equals to mg. So I can substitute that into my equation over here. Let's go over here. So this is mg. This is mv squared over r. So now I can potong, because that is what I love to do. And now I can substitute the values because I have simplified my equation somewhat, walaupun tak berapa sangat. So V is 25.56. Mana dah tadi? 25.56 meter per second. 25.56 squared over the radius. This r is radius, so it's 85 meters. Mu and G is just 9.81. So your mu is, can someone calculate that for me? What is the answer for mu?
I got 0.7835.
3.5. What is the unit for mu?
No units.
No unit, correct.
Unit.
If you want to give me 4 decimal places, yes, you can. That's the best. But the minimum that I require on your test as answer is 0.78. At least 2 decimal point. If you give me 1, tak cukup markah. Okay, tak cukup spesifik lah. Okay, so always 2 decimal points at least. Ni at least If you want to give me 10, boleh. Okay, tak ada masalah. Okay, so this is your net force in the radial direction. And you're asking me, doktor, walaupun tak tanya sekarang, tapi saya tahu mesti ada orang tanya, doktor, kenapa AC kita is not part of the free body diagram? Ada tak orang boleh jawab tu? Does anyone know why is our AC not part of the free body diagram?
Acceleration is not a force.
Acceleration is not a force. Betul, but it can be if you multiply it with mass. Okay, so remember that we had tapi betul free body diagram kena ada force sahaja. That is correct. Remember last time we learned in chapter 3 pun masuk test. I have a car that is speeding in this direction. This is my A, acceleration. So to draw my free body diagram, I said, okay, that the friction, kinetic friction because it's moving. I have a driving force that I call SFD. I have reaction force, I have mg. Okay, FD ni given this is me making it up. So ada FD Ni saya buat soalan random. Okay, naik atas balik. Sekejap Okay, so I draw my free body diagram. My acceleration is in this direction. What do? I said, okay, so the condition for Fx, which is the same direction as your acceleration, the condition is I have acceleration to the right. So I'm going to say that to the right is positive. So my condition becomes MA. What is in my free body diagram in the X direction? It is FD positive because it is in the same direction as my acceleration minus FK. So my equation becomes MA FD minus FK. And then you have to write down your net in the Fy. Do I have acceleration in the Y direction? No, I'm not flying unless my car is flying, but it's not. So in the Y direction, I am in equilibrium, which means that it is equal to 0. What is in my Y direction? In my free body diagram, I have positive R minus mg. So now my equation becomes 0, R minus mg. Okay, so what I'm trying to highlight here is my acceleration does not need to be part of the free body diagram. It becomes the condition to say that it is not in equilibrium. When I don't have acceleration, no acceleration, right? No A over here. Equilibrium. Sama juga in the radial direction. We are talking about X and Y here. But when we are driving on a circular road or anything circular, we have net in the FR. What does it mean? It's not in the X, it's not in the Y. It's net in the radial direction. What is radial? Circular lah. Radial, radius, sama. Radial, radius, pointing towards the center. Okay? Pointing to center. So that is net in the FR. What is in the net in the FR? What is the condition? AC, MAC. What is in the free body diagram? FS. FS is in the same direction as my AC. So I write it here. So now my equation becomes MAC equals to FS. Okay, and then plugging in the values should be easy lah. The crucial part here is to draw your free body diagram correctly and then writing the equation. Okay, kalau yang tu salah, memang semua yang lain salah lah. No matter how good you are with numbers, if your free body diagram is wrong, you will get wrong answer. Okay, any questions for this one? Okay ke? Ke saya laju sangat? Panik ke? Senyap je. Okay. No questions Right, I'm going to continue. What is the last question? Dah terbuang pula. Sekejap. Kita tengok balik WhatsApp. Third question. Sekejap korang. Okay, 13. So the third question is, let me write that down sebab saya dah terhilangkan. Insert each break. Please cooperate. No, sini. Okay, tak apa. Saya sini. Each break. Each break. Okay. Number 3. Okay, number 6. A car is driving at constant speed over a hill, which is a circular dome of radius 240 meters. So what is the maximum speed? The car can have, the car so that it doesn't leave the top of the hill, leave the road on the top of the hill. Okay, so how do we answer questions like this one? Okay, so let's draw the diagram first to understand what the question is asking us. So it's on a hill, a circular dome, which means that we have centripetal acceleration. It's about circular. So the radius says that the radius is 240 meter. Okay, I don't want to write it there. Nanti susah nak lukis free body diagram. So let me write it here. So this is my radius, 240 meter. What is the maximum speed so that the car can have so that it doesn't leave the road on the top of the hill? Doesn't leave the road on the top of the hill. What can you understand from this equation? From this problem? What does it want you to solve? Anyone? Siapa? Azri. What does it mean by this question? Apa yang question ni nak? Are you still there?
Ya, doktor.
So dia cakap apa kat sini? Apa yang awak rasa? Rasa-rasa.
Dia nak apa?
Dia nak apa? Tak buat lagi
Saya tak buat pun Adi.
Okay, tapi kalau awak nak teka, apa yang awak boleh teka daripada soalan ni?
Tak pasti betul.
Tak boleh teka.
Supaya kereta tu tak jatuh ke bawah.
Itu tak jatuh ke bawah. Kalau tak jatuh,
Sebab
condition apa yang kita kena ada?
VYH ke doktor? VYH equals to 0 ke jadi dia?
VYH equals to 0. VYH apa?
Guna Fnet.
Guna Fnet, okay. Guna F.
So kalau car tu move faster sebab dia kata maximum speed. Maknanya normal force dia go to zero lah kan?
Maksudnya normal force dia go to zero. Betul. Normal force. Betul. Betul. Siapa yang jawab tu? Syakirin Thank you. Betul. Soalan macam ni bila tanya doesn't leave the road on the top of the hill. Maksudnya dia maintain contact. Betul tak? What is the type of force that maintain contact? R or normal force. Betul. Okay, soalan ni tak direct, but you need to understand what it is asking for. When it doesn't leave the road on the top of the hill, it means that it is in contact with the top of the hill. And for you to have contact, your R must be equal to 0 or greater than 0. So it should be greater or equal to 0. So that is how you solve this type of question. So tadi Syakirin cakap R ni normal force. Okay. Is there another name for R? What is the other name for R? Ada lagi dua. Normal force lagi. Tak ingat dah? R. What is R?
Reaction force.
Reaction force. Lagi satu. Yang kita dah
Resultant force.
Bukan. R bukan resultant. Ni bukan resultant. Bukan. Reaction lagi satu. Yang bila kita discuss elevator case tu. What was changing in the elevator case? Kejap rasa berat, kejap rasa ringan. Apa yang rasa ringan, apa yang rasa berat tu? What is it called? Apparent, dah kasih hint dah ni.
Apparent wave.
Yes, apparent weight. So when the question asks you what is the normal force, what is the reaction force, what is the apparent weight, it means disuruh cari R. Okay, kalau nama-nama ni tak tahu macam mana nak solve, betul tak? So these are the three variations nama R. So normal force, reaction force, apparent weight, or does not leave surface, or maintains contact. Semua referring to R. Okay, so these are the keywords. Okay, so now that we discussed what R is in question, so now we can solve for R. What is the maximum speed that the car can have so that it doesn't leave the road on the top of the hill? So for this type of question, you have to find the net force in the radial direction. Okay, so saya nak tanya Balkis Badrudin. Ada tak kat situ? Saya ingat-ingat lupa je nama ni. Ada tak Balkis kat situ?
Yeah.
Okay. What is my net in the FR? What should I do first untuk tulis equation ni? What should I do first?
mg minus with normal force.
Mana awak tahu mg minus normal force? What did you base this off?
Since mg F equal to mg, and then the normal force must subtract since n is 0
Since
in a circle.
Okay, tapi awak punya equation ni tak ada free body diagram lah kiranya.
Tentunya ada.
Okay, so the first step is free body diagram. Sebelum beria-ria tulis kita punya equation, you have to have your free body diagram. Okay, assume that your car is this dot. Sebab saya dah malas nak lukis car saya selalu buruk. Okay, so your R is going upwards, right? You have contact, you have mg. Where is your AC? Where should your AC point?
The center.
Towards the center, yes, correct. So this is my AC. Do I have friction?
Yes.
I should have, right? Dia tak cakap frictionless. Friction kinetic. Okay. Okay, not sure if friction kinetic is relevant to this question, but if you want to put it in your free body diagram, boleh. Okay, so now that we have draw our free body diagram, we determine our AC is in this direction. Now we can write the equation. Okay, always start with your free body diagram. Okay, tadi saya nak trick je. Kesian Balkis. Okay, so oh my god, what happened? So now my net in the FR is equal to, what is the condition? Ada AC going downwards. My AC will always be positive. So that means whatever that is going down becomes positive. Whatever that goes up is negative. It depends on the direction of AC. If AC is positive downward, then everything downward is positive. If AC is pointing upward, then everything upward is positive. Ikut direction AC untuk positif. Okay, ikut direction AC for positive. Okay, so now that we determine AC is our positive, MG is positive sebab MG is in the radial direction, dia sama direction dengan AC minus R. Okay, bukan sebab R akan jadi kosong kita kena tolak, bukan macam tu. Kita tengok free body diagram, tengok direction dia, baru tulis dalam equation. Jangan sesekali teka apa yang dalam equation, tengok free body diagram, okay? So plus mg minus r. So now your equation becomes MAC mg minus r. Your MAC is mv squared over r minus equals to mg minus r. So now it's asking what is the maximum speed that the car can have sebelum dia terjatuh, supaya dia tak jatuh, supaya dia tak jatuh. Maksudnya the minimum R yang dia boleh ada is 0 lah. 0 is the limit before dia terjunam ataupun dia lost contact. So now I want to rearrange this to have my R as the subject. So mg minus mv squared over R equals to capital R, or my reaction force. R should be greater or equal to 0. So I'm going to set this as 0. mg minus mv squared over r. Maximum speed is attained when r equals to 0 sebab laju lagi daripada tu memang terbabas. Tu yang berlaku dekat kereta lah. When it goes terlebih speed, terlebih laju, terbabas kan. Terbabas, terjunam ke, terjatuh gaung ke, na'udzubillah. So kita ada maximum speed yang kita boleh ada before terbabas masuk gaung. Kita tak nak terbabas lah. Okay. So now I can find for my speed, which is mv squared over r equals to mg. So ini just math je lah. So gr square root is your maximum speed, which is 9.81 times radius, which is 80, sorry, it's 240. 240 kan? 240. Macam nak potong. Okay, 240. Square root that is your Vmax. Okay, boleh je nak tulis pada sini Vmax. Okay, so tak tahu jawapan dia apa, tolong tekan calculator jap.
.52 meter per second.
48.52.
52.
Thank you. Meter per second. So the maximum speed that the car can have sebelum dia jatuh gaung is 48.52. Kalau speed dia 50, R is less than 0, no contact, terbabas. So the speed yang dia boleh ada is this much, tu maximum dia. Okay, so soalan ni, what we had to understand was this part. This was the tricky part. Okay, and then your free body diagram lah, of course, writing your free body diagram correctly, drawing your free body diagram correctly. Okay, any questions for this particular question? Everyone's okay with the explanation? No confusion so far?
Okay.
Tahu. Kalau confused bagi tahu Okay. Dah suara saya hilang ni. Okay, so question chapter 7 pula. A centrifuge. Okay, nak buat soalan 1 ke soalan 2? Kita tak cukup masa ni. Tinggal 10 minit je. Mana lagi susah? 1 ke 2?
2.
Nak 2? Okay.
Satu.
Satu susah. Okay, kita cubalah buat dua-dua. Lepas ni kelas apa?
Bio.
Oh, bio. Okay. Bio Kak Ani pula. Bio Dr. Ani kan? Ke tak?
Dr. Dania.
Dania.
Oh, Damia. Okay. Silap. Dania. Damia tu kelas korang. Apa tu yang nak buat tadi? Escape. Saya tak nak draw. Hello. Okay. Bio dah ada assessment tak? Oh, ada kan yang korang cakap susah tu kan? Lah, fizik pun susah. Itulah, semua susah. Okay, chapter 7. But insyaAllah test nanti kita orang akan moderate betul-betul so that at least the average student can do well lah. Okay. Hari tu punya soalan memang susah. I have to admit. Sebab dia tak moderate betul-betul. But congrats untuk yang dapat jawab. Very good. A centrifuge in a medical lab. Kenapalah saya pergi buang dokumen tu. Medical lab rotates at an angular speed of 3,600 RPM. When switched off, dekat bila tutup, when switched off, it rotates through 50 revolutions, rev, before coming to rest. Okay. So dia cakap final angular speed dia kosong lah. Find the constant angular acceleration in radians per second squared SS of the centrifuge. Okay, jangan tulis macam tu tau, tulis second squared betul. Ni saya nak cepat. Okay. Nak buat 2 terus lah. And automobil, tak payahlah, nanti tak sempat. Okay, so let's do this question really quickly. Okay. Centrifuge, kita dah belajar centrifuge tu apa, benda yang rotate tu untuk separate blood, plasma to apa? Red blood cell lah. Saya tak tahulah bio ni, but benda tu lah. Okay, so it rotates really fast to separate benda yang lain density because it depends on mass. Because angular acceleration depends on mass. Okay, so a centrifuge in medical lab rotates at an angular speed of 3,000 RPM. So speed omega, angular speed, omega is 3,600 RPM. What is RPM? It is revolutions per minute. Rev per minute. What do you do with this type of unit? You convert it to SI always. So becomes 2 pi. Okay, this is the easy part. 2 pi radians, don't forget your radians, over 1 revolution times 60 seconds, times 1 minute. Minute nak hilangkan, so it should be up here. 1 minute over 60 second. Okay, so potong-potong, rev, minute with minute, so you get whatever that is. Okay, and then when switched off, maksudnya dia tengah putar-putar ni, waktu awak tekan off, so dia akan move slowly, dia akan decelerate. The acceleration decreases, right? Sorry, it decelerates lah, the speed decreases. When switched off, it rotates through 50 revolutions sebelum it becomes rest. So this is your initial angular acceleration. This is your final angular acceleration. Sebab last kali dia jadi rest. So speed equals to 0. Dia cakap sebelum dia mati, sebelum benda Allah ni habis putar, sebelum dia stop, dia berputar sebanyak 50 revolutions. So theta is 50 revolutions, and we know that theta is equivalent to S in the linear world. In the angular world, it's theta. So this is the displacement in the rotation, this angular displacement lah. So how do you convert this? 50 revolution, you should know this by now. 2 pi, 1 pi radian over 1 revolution. So that is whatever that value is. Find the constant angular acceleration in radian per second square of the centrifuge. It's asking what is alpha. Okay, so this is kinematic equation. You have your initial speed, you have your final speed, you have your displacement, which is your theta, and it wants you to find alpha. How can we use the kinematic equation? Only when we know that the angular acceleration is constant. Kalau dia tak constant, acceleration tak boleh pakai kinematic equation. Sama juga dalam linear world, kalau acceleration tak constant, kena separate into different sections. Kan kita dah belajar dah. Okay, so constant angular acceleration maksudnya kita ada satu section sahaja, only one acceleration that we have to look into. Okay, so kinematic equation saya tak ingat angular punya, so selalunya saya akan cuba solve v squared u squared plus 2 alpha s. Do I have this? Yes. Do I have this? Yes. Do I have alpha? I want to find it. Do I have s? Yes, I do. So this is omega final, omega initial plus 2, oh ni bukan alpha, ni a, silap. 2 alpha theta. Okay, that's just my method. If you can memorize this equation, good for you. Saya memang tak ingat langsung. Saya memang kena convert my linear to angular. Okay, kalau boleh ingat bagus. Alhamdulillah. Okay, so final is 0. Initial is berapa tadi? Kita kena kira. Ada orang dah kira tak? Times 2 divided by 60. 376.99. Kalau saya salah bagi tahu kadang saya salah tekan calculator. So this is radians per second. And this dude over here is 50 times 2 pi. 314.16 radians sahaja, because that's displacement. So masuk saja value dia 376.99 squared plus 2 alpha theta is 314.16. Okay, so you can use your calculator and solve for alpha. Yay. Okay, so any questions about this one? Senang je kan? It's just identifying what is your initial, what is your final, what is your displacement. And then finding the right equation untuk substitute those values. Is everyone okay with this one?
Doktor, we will get the negative value.
Betul? Memang patut negative pun because you are decelerating. You are decreasing in speed. Kalau positive acceleration, you are increasing in speed. Betul tak? Kalau negative acceleration, you are decreasing in speed. Bila kita turn off, dia makin slow kan? Makin slow, makin slow. So acceleration, negatif lah.
Alright, thank you.
Memang negatif jawapan dia. Okay, so let me write that. So untuk orang yang blur-blur ni. Kalau speed increasing, you will get positive acceleration or positive alpha. Sama je. Positive acceleration or positive alpha. If your speed is decreasing, which is what is happening here, kita turn off centrifuge tu sampai dia stop, sampai dia mati terus tak ada speed langsung kan. Negative acceleration or negative alpha. Okay. So this is how you check back on your answer lah. Kalau negatif ke positif ke, betul ke tak ke. Okay, sempat tak kita nak buat last question ni? Ada 2 minit lagi ni. Kalau tak boleh nak continue, oh nanti awak punya bio Bio will start right now Is it at 11 or is it at 12?
At 11.
Oh 11, okay tak apalah, kita continue next time lah. Okay, so that is it from me. Ada tak orang yang tak hadir? Saya nak tengok sekejap. Dari segi kehadiran. So this is 1, 2, 3, 5, no 6, 12, 18. Ni siapa? Tak nampak. 18 plus 6. Macam mana? Okay, bye korang. You guys can go.
Thank you,
Thank you, Doktor.
Okay.
Thank you, Doktor. Thank you, Doktor.
Thank you, Doktor.
Thank you,
Thank you, Doktor.
Thank you, Doktor.
Welcome. Bye.
Doktor.
Thank you, Doktor. Thank you, Doktor.
Korang tak balik Adam Daniel? Kat UPM Kesian. Take care. Bye.
Bye.